Right. Live stream. Not true. Yeah, that's not true. Wait. Yeah, second to last live stream. Although next live stream is gonna be a lot less time. It's just a lot of grading. This is all I've done so far today. Hey, Michael. Welcome. Hello, Aspen. Welcome, welcome. The senior parade thing I had to run off to last time was pretty fun, so that was cool. Several of your classmates came through the parade 5 or 6 times. The back of trucks or coming through sunroofs in somebody's car. Hello, Carly. Welcome, welcome. So this should be another relatively short stream because I'm going to ask you to try out a couple, and I'm going to go over these, and we're going to kind of see where people are. Then we're going to do an AP response question with areas and volumes, which maybe surprisingly usually is exactly the difficulty of any other written question because area and volume questions already have enough nuance to them. So like these questions here are essentially AP free response questions. Hey Daikun, hey Nick, welcome. Got a first period. Today's actually a very Liberty day. I'm gonna send out my weekly emails and do a little more grading after this stream, and then I'm gonna be hanging out with Mr. Hassenfleck until my wife's done with stuff. He lives really close to me. Keeping today Liberty. Like, hey Chelsea, welcome, welcome. Speaking of calculus, I'm teaching 4 sections of calculus next year. Got approved for teaching calculus in the high school next year, so I have 3 APs and 1 non-AP calculus. Which means I make more money. Hey, teaching college and the high school classes actually pays you more money, whereas teaching AP classes doesn't make you more. Which is ironic. Am I still averaging your grades with 100%? Yes, if you have 100% in the assignment category, I am averaging your grade with 100%. And just so you know, that averaging won't happen until Monday the 22nd June, because grades are due at 4 p.m. on the 23rd, but I really want to have them done on the 22nd. And so I'm going to be going through and doing all that adjusting. Although I can't even do adjustments, I have to do some override or something, so I got to figure out how to do that, so that's another stuff. Because the district decided we have to do something different for some reason. Hey, Bryn. Welcome, welcome. Oh, yeah, you guys are all going to have cruise next year. What, right? Like, everyone who has calc as a not senior ends up having cruisage the next year. Most people go to Calc BC, but those that don't go to Calc BC still end up going to stats usually. So, painting. When you assignment category, do you mean academic or homework? Yes. Yes, both. The assignment categories are the academic and homework. It's basically like, since school came out, did you do all the things? If you did all the things, you're chilling. Didn't do all the things, you're slightly less chilling, and I'll be averaging with like 90%, 95%, or 85%. Yeah, just a reminder, if you catch up on homework, please email me. I just went through all my emails and tried to update everyone. I did not put in the most recent assignment, the one I went over last live stream. By the way, if you haven't done the most recent worksheet assignment, I went over it last live stream, so if you didn't see that, you should be able to finish it pretty easily if you watch. Yeah. And kind of as per like a month ago, if you finish the questions on here, tell me you're done. Yeah, Daikun, I think I already have you recorded as having done all your work. Right? Yeah. You're chilling. Although averaging your grade with 100% Daikun does not really do anything, so I'm not going to end up changing your grade. Sorry, I'm not going to change your grade to a 98.65%, because that's just not worth my time. An A is an A. And man, that even if we had A pluses, you'd still have an A plus, so you're chilling either way. Eh. Yeah, in case you're curious, I do expect you to be working on these questions. If you are, fantastic. You're welcome to use Desmos to solve them. Setting up the bread and butter of these. When our AP score's out, they sent an email recently. I think it's like in a month or so. Have that email. July 15th. So exactly a month from today. 8 a.m. Eastern time. So what is that? 11 a.m. time? And teachers and students all have access at the same time. It's just a big dump. Yeah. Is there anything else interesting? Seniors can have a free score report sent to college. Exception testing, but I don't think anybody who isn't a senior doing exception testing or is on eligible. Some people just didn't take the AP calc tests. A lot of people who like dropped the class, so that's. So yeah, feel free to throw a done in there when you are finished with the. Otherwise, I'll just keep talking to myself. That's fun. Got our first stat. How much are grades going to change after averaging? For a lot of seniors, they changed a ton. All of the seniors who did a lot of their work, uh, like, so did all their work during this time, all the online assignments and all that kind of crap. Saw huge grade changes, like D's to B's, that sort of thing. So I mean, it's literally I'm averaging with whatever your homework grade is, so they're gonna change a lot. A fair amount of people did like half their homework, and those people's grades I'm not even just change them. People who are failing who did 0 of their assignments are gonna stay failing / incomplete since we're not allowed to give Fs or whatever. And that's kind of it. So that's not too complicated. Solving this first one. Will my first semester grade change if you get a 5? Yeah, if you didn't get an A first semester and you get a 5 on the AP test, your grade will change, but that won't happen until gosh, I don't know, next year. Mid to late September usually is when that will change. So that's what to look forward to or something. Oh, is that something you look forward to? Probably. Grade changing is usually a good thing. Hey Rose, welcome, welcome. Don't worry about it. We haven't actually, we've mostly been answering questions, and people have been working on these questions here. You'll show up in time for me to do them, most likely, because I'll probably be doing them shortly. Wanted to make sure I had all the answers before I start doing them. Let's see, villain. Cool. Wait for another done or two, and then I'll start mobbing. I believe I have all the decimal answers up in their glory. My screen. Nope. Now I do. I forgot a squared. There are a lot of squareds in that second question. Second integral. Wait, so if you already have a good grade, that's not going to change, right? Yes, that is not going to change. Grades are going up or staying the same. That's the general rule. Yeah, that actually works for everything. So I'll wait for another done or two, and then get rolling here. Go check to see if the patch notes are released. Video game. That's a productive work hours. Nope, still not yet. This is perfect timing. I thought they were going to release right at the start of this. I was going to be sad. Winner. Righty. So since we are 15 minutes in, I think I'm going to start rolling. I mean, I can wait another 7 seconds. And I'll officially be like a very appropriate. Okay. 15 minutes in. Okay, if you draw a picture for the first one, you should have gotten your region looks a little something like this. X equals like that. Wait, no, revolving around x equals 5. Goofball. Okay, sorry. Y equals 2x, y equals 2, so it's going like over 1, up 2, so this is 1 comma 2. Corner where this meets. And the y-axis, so we're actually talking about this region here. And we're revolving this around the line x equals 5, which is out here in space. Okay, so we have two radiuses because the line we're revolving around is not attached to our shape. Our outside radius is always 5 because it goes from the x equals 5 to the y-axis. So I know big R is 5. Little r is 5 minus whatever the x-coordinate of the line is. And the x-coordinate of the line is this equation solved for x, which is x equals y over 2. So it's 5 minus y over 2. That's little r. Okay, so now we just plug it into the equation. Pi, I'll figure out my bounds in a second, of big R squared minus little r squared. Alrighty, and dy. And since my bounds are y, I'm going from 0 to 2, because the graph ends at y equals 2, that's a bound of our thing. And so our y bounds are from 0 to 2. Just some added hints based on stuff we talked about. X equals 5, the line we're revolving around, is parallel to the y-axis, which is why we're in terms of y. We also got hints from the fact that we needed an x distance, and x is in terms of y in the line equation, and other pieces like that. Now, if you type this into like Desmos, what I got is 29.322, or 321 if you truncated. Liam did it right. Huzzah. And that's that question. Alright, the second one was actually kind of easier. The thing that made it harder was figuring out where these meet, because this graph looks a little something like this. Like this. And figuring out where these meet is a little tricky. If you have Desmos, you just like graph them and see where they meet. But you actually can do this by hand. And so I was gonna demo how to do that just real quickly because it's not that hard. You subtract x squared you set them equal because that's how you find where they meet. You subtract x squared from both sides, and then you just factor this, and you get where they meet. So you take out a 2x, you get 2 minus x squared. So they meet at 0. No, they don't. They don't meet at 0. So they meet at these. Did I goof? Oh no! Oh no! Oh no! Sorry. I factored wrong. 2x times 2 minus x. So they meet at 0 and 2. And so those are our bounds, so I put this in the wrong spot. Let me fix my graph location. Doink. 4x minus x squared is 0. Yeah, it's like that. Cool. Looks more like that now. And these meet at 0, 2. Fix-a-roonied. And my one on top is the upside down parabola because it's like concave down on that interval, so it's kind of bubbling up. It has a bigger area there. We could also see this just by graphing these two functions. And if you graph the two functions, it looks like roughly this picture. Okay, now that we know these meet at 0 and 2, all we do is integrate from 0 to 2. And we do top function minus bottom function squared, like this, big R squared minus little r squared. And we plug that equation in, and I goofed up and wrote in the wrong equation, so I'm going to fix my bounds real quick and tell you the answer I get in Desmos. I got 33.510 for that one. Dope. Again, easier if you plug these all into Desmos and just look at where the graph meets. And I plugged it into Desmos to solve because I was too lazy to actually do all the math. Which you can be too. Hooray. Are people cool on these two questions? Sorry for a little bit of circular stuff on that second one. I goofed up when I did it the first time. Hang out a second, and then I'll move to the free response question if there are no questions. All right. Onwards and upwards. This is our free response for today. Right here. And in this question, we say, let R be the region in the first quadrant, bound it like, okay, R is very obvious, it's right there. Natural log of X is this thing, and 5 minus X is this thing. This has a very typical amount of steps to it. It has an area question, a cross-section question, and then the last one's a little bit of a weird one. It's taking area to a new level. It's saying, hey, if I cut this thing in half, where do I cut? And so that's a little bit tricky. And yes, you're correct. It's absolutely calculator active. Because figuring out where those meet without a calculator is a little bit of good luck land. So I want you to try this out for a little bit, and then I'll probably start going over this in, I don't know, 10 minutes or so, 5 minutes or so. It kind of depends on when people start putting in their dones, when people just want to see it. I'll give people a chance to try this guy out, and I'll solve it on my Desmos here. And just a little hint, all the homework is for today is to do a free response question with the areas and volumes. So it's essentially like a 3-question homework because like this, it has 3 questions for 1 graph. And that is the last homework of the year. Yeah, Daikun, we're not going to do that, mostly because that was in preparation for the AP test. This is, in essence, what we would be doing in that. What we're doing right now. Hopefully next year will be more normal, but you guys are probably good enough at stats to realize that the US is not fighting the coronavirus particularly fantastically. Like, oh my gosh. Just look up COVID statistics for any other first world country, and then the United States. And look at the negative slope of the curve and realize how crappily we've done. Holy smokes. The only countries doing worse than us are like Russia and not first world countries. It's that's kind of how long the list is. Sweden's also doing kind of bad. I think that might be it for that list. Because the other countries doing worse are like Brazil and India. Although India, we should give a pass on because they're still a little behind, but probably doing a lot worse. Statistics take a while to come out of India. Yikers. But anyways, just rambling. Well, hopefully you are trying out this question. Well, unfortunately, so are we in a lot of cases, Raquel. In the United States, we are largely ignoring coronavirus. Pray. Turns out if we had taken it seriously for just maybe a month or two longer, maybe we would have gotten rid of it. Yes. Sweden never really shut anything down. So we like begrudgingly shut down for a tiny bit and then kind of reverted to partisan politic in infighting, riots, etc. Things that don't contribute well to COVID stuff. Uh, and yeah, we basically started our shutdown too late and then ended it too early, and so now we have a lot more of it than other places. And a lot of places are raising. If you think Washington's out of the woods, King County's actually basically follows the European curve. But if you look at Yakima County has about a tenth the population of King County, and has almost half of our cases now, which is crazy. That's about 5 times the amount per population per person. Just nutty, 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 and it's still spiking upwards. And like Yakima County is not the only county that's seeing that. They're just the most populous one in Eastern Washington that is having that issue. It's kind of crazy. Feels bad. um, no, it's not just because of the agriculture. It's largely hitting the agriculture sector there, and that's what gets reported on because a lot of people rely on Yakima's agriculture sector for a lot of things. But it has to do with people just didn't take things seriously. If they had been, because even on the farms, like I've worked on farms before, I know what the working conditions are like, and there are ways to social distance, and there are ways to not social distance, and it costs a little bit more to social distance, and farms don't like spending more money on migrant workers. So I'll just leave it at that. Uh, and I should probably start moving into solving questions and things. Although I haven't seen any done, so I don't know. Maybe I should hold my horse a little bit. The horse. Can you edit idioms, or should you keep them the way they are? That's really the question. Huh. One of the beautiful things about this question, which many of you have probably realized, is B and C don't require you to solve anything. It's literally just set up the integral. A actually requires you to solve stuff. But yeah, that's kind of cool. I like these kinds of questions. For that reason. I'm gonna go in about 20 seconds and start going through this. done, but C is iffy. C is just iffy. It's it's harder than the other questions, so. Alrighty, let's go. Alright, first of all, this is natural log of x, this is 5 minus x. If you graphed these meet at 3.69344, roughly. So that's like the first important thing you should do in this question. You also kind of are curious potentially about the y value down the road, and so the y value these meet at is this. Let's see. So that's the point at which they meet. Cool. All right, now let's actually try to do A. So for A, all we do is we're trying to find the area of the region. There's two ways you can do this. You can integrate from 1 to where these meet. One on the bottom. 1 to 3.69344 of natural log of x dx plus the integral from 3.6934425 of 5 minus x dx. And this will get you the answer. And that's totally legit. Or you could look at it from this direction and just do the integral from 0 to 1.30656 of top function minus bottom function 5 minus x minus natural log of x. And, or sorry, I goofed. You have to actually convert these to y. And if you convert these to y, you get x equals natural log of y. That's our bottom curve. And if we convert this to x, solve for x in this equation, we get x equals 5 minus y. And that's our top equation. So 5 minus y, and oh my gosh. I am being a very embarrassing math person right now. We e both sides to get rid of the natural log, and so it's e to the y. So it's 5 minus y as the top curve, e to the y as the bottom curve. Now, either of these worked. These were both legit. Convert it to y's, use y's, only have one integral, or keep it in x, have two integrals, because we have two different functions on top. All right, that's A. That's the one where I have to like write a bunch of crap. B and C, it's just writing integrals. All right, for B and C, region R is the base of the solid. We're perpendicular to the x-axis. We're doing squares, so easy money. We're integrating sides squared. It's perpendicular to x, so it's a dx integral. Yeah, for this one, since we're going in the x direction, we actually have to have two integrals because we have to account for the two different parts, the part where natural log of x is on top and the part where 5 minus x is on top. So we're going to have the integral from 1 to 3.69344 of natural log of x squared dx. That's the first part with squares going up into 3D. And the second part with squares going up into 3D is this part. So it's basically my first answer to the part A, but with the inside squared. That's it to make squares into 3D. It's not going around the x-axis. They're actually cross-sections perpendicular to the x-axis. So we're not going around anything here. There's no revolution. It's just side squared, and side is the distance from the x-axis to the curve, which is the equation of the curve in both of these. And that's it. So, yeah, I mean, the easiest way was probably just to do this for the first one, and then just add squareds for the second one. Yeah, chillin'. And then C. says the horizontal line y equals k divides R into two regions of equal area. So what we're trying to make is a cut. It's probably somewhere around maybe here-ish, where this area and this area are exactly the same. So we're trying to find this spot. So the way we're going to do that is by defining this point where these things where this oh, did I goof? Y equals k? Oh gosh, I meant to cut this way. Oopsie daisy. Oopsies. Oopsie, oopsie, oopsie. Yeah, so a cut here and here, which cuts it into two equal areas. I was cutting it into the areas the wrong way. Sorry. Yes, thank you for putting me on the right path here. This line where we cut is y equals k. They tell us that in the question. The horizontal line y equals k cuts this into two individual regions. So, cool. So what we want is where the integral from 0 to k of top function minus bottom function, which in this case is top function is the big radius, bottom function is the little radius, is equal to the integral from k to 1 of top function minus bottom function. The line minus the curve again. Now, this one actually benefits from us looking at it in terms of y in A, because I'm going to be using these values for my integrals. Now, my first integral is the integral from 0 to k of top function, which is 5 minus y, minus bottom function, which is e to the y. Chillin'. I don't need to do any squared or anything because I'm looking for area. So I'm not actually going into 3D. I'm just trying to cut this into equal areas. And I want where that's equal to the integral from k to where this ends, 1.30656. That's my end point that I calculated in the first part. And of top function minus bottom function, same dudes. And that's that dude. So this is where I'd want these to, like, I'd want these two integrals to be the same. Now, there is a little bit of a cheat code I can do, because what I did in question, or part A of this question, was if you solve this integral, you get 2.986, or 2.985 is fine too, if you truncate. So I could say, hey, I just want the integral from 0 to k to be equal to half of this. So all I can do is, I don't even need to actually do these two integrals, although saying these two integrals are equal isn't wrong. All I have to do is set the integral from 0 to k, or the other half of it, the integral from k to 1.30656, either of these equal to half of my area of the whole thing, equal to half of, what is that, 1.9, 93? 493? Yikes. I can totally divide. Good. So this one actually had some flexibility with what you could do for the right answer. Setting these two equal was a right answer. Setting these two equal was a right answer. Or setting the first and last equal was a right answer. And all of those were actually okay. All you needed to do is have two of these set equal of these three possibilities. So there are actually three right answers to this question, which makes it pretty nice. Even though it feels a little janky. I just realized this looks like absolute garbage because it's 3.96 blah 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 I wrote here. So I'm gonna write that to make it look nicer. Those are the insides of the integral. And booyah. Okay, did I lose people on that, or did people actually follow that somewhat? Doot, doot, doot. I think the problem I assigned on online is easier than this part C is. Or at least more traditional, like you're revolving around a line instead of doing some janky area thing. I'm not sure if that's easier. Just more traditional. No questions? Alrighty. I guess I will be happy to answer any questions if they show up later. But otherwise, your homework is one FRQ, not totally dissimilar to this one, online. It's just one free response question, but it does have an A, a B, and a C, asking you area, volume, etc. It should not be too brutal. I'm going to go over that with a nice short stream on Thursday, and then just basically remind people to turn in homeworks, and that's it for Thursday. I'm not going to be assigning anything on Thursday. I'm just going to be going over the homework, maybe trying to practice, and then calling it a day, and that will probably be the end of the year. Yeah. So if people are chilling, I think we're done. I see no questions. And yeah, I know OSPI said we're going to be starting, going back to school with face masks next year. But just to be clear, because almost everybody is misreading this, OSPI has to say that because if things are chilling, like if the vaccine comes out in like a week or something and everybody gets it and all that kind of crap, um, everything is basically, it needs to be ready to go. So we need to actually plan on going back, even if we're not going back. That's all the last OSPI email means. So if things aren't safe, they're not going to make us go back because they just sent out that email. They sent out that email because they need you to know that they're going to be ready to go back if they can go back. So don't panic too much about school next year. You're gonna be getting updates all summer probably from the school district and the state and whatever. Yeah, anyways, have a good one, y'all. Please turn in that assignment because kind of after Monday of next week, I'm not gonna have a ton of time to put in grades, so do not last minute things and try to get everything in by the end of this week. And otherwise, yeah, we'll probably do like a face cam stream next stream just for the memes. Because why not? Alrighty. Later, guys.